Why discuss deep learning? Machine learning, which has been around for several decades, covers a variety of algorithms that enable machines to learn and grasp hidden patterns in data. These algorithms can make predictions based on what they have learned. However, many of these algorithms struggle when the volume of the data becomes large and the complex patterns are harder to capture. On the other hand, unstructured data such as texts and images typically require an understanding not only of data as a whole, but also of the regional relationships, such as words in a sentence and pixels in an image. Deep learning, a subfield of machine learning, involves neural networks with many layers, hence deep, that can learn hierarchical representations of data. This multi-layered approach allows deep learning models to capture complex patterns and structures in data that traditional algorithms struggle with. The advanced conversational chatbots we interact with, the self-driving cars navigating our roads, and the recommendation systems that suggest products or content are all products of deep learning. These applications are transforming industries and impacting our daily lives in profound ways. Intro to the topic of neural networks. High level. The core of deep learning is neural networks. Neural networks are a variety of computational models inspired by the way biological neural networks in the human brain process information. The intuition behind these deep learning models is illustrated in the above image. In the image, there are 5 columns of nodes. Each node in the first column represents various features of the input data, such as ages, incomes, words we write and speak, or pixels in an image. As we move from the leftmost column to the right, the nodes represent progressively more abstract representations of the data. The connections between nodes, depicted as edges, signify the relationships and pathways through which information flows from one layer to the next. These edges can be thought of as pathways to the truth. Starting from the input layer on the left, the data is processed through these pathways, ultimately leading to the output layer on the right, where the nodes represent the final predictions or categories we aim to determine. When we train a neural network with data, we allow the network to learn the optimal paths to reach accurate predictions. Once training is complete, the neural network can navigate these paths efficiently to make predictions based on new data. Different input data can lead to different pathways and, consequently, different predictions. This process is akin to how our brain transmits information through neurons to generate appropriate responses, such as running, sitting, or laughing. This mechanism enables neural networks to capture complex patterns in large datasets, which other machine learning algorithms often struggle with. Modern advancements in neural network architectures, such as transformers, have further enhanced their capabilities, allowing them to understand human languages and power applications like ChatGPT. While the detailed workings of neural networks involve complex mathematics, this intuition provides a foundational understanding of their powerful capabilities and revolutionary impact on various fields. However, neural networks come with their own set of limitations. One major challenge is explainability. Neural networks are often seen as black boxes because it can be difficult to understand how they arrive at specific decisions. This lack of transparency can be problematic, especially in critical applications in the healthcare or the financial service sector, where understanding the reasoning behind a decision is crucial. For example, when we develop a credit underwriting model for loan lenders, we need to pay close attention to the Fair Credit Reporting Act, where the rejected applicants need to be informed of ways they could improve their approval rates. In this situation, as the decision-making of a deep learning model could be a black box, a deep learning model can be less desirable in this use case. Additionally, neural networks are computationally expensive. Training deep learning models requires significant computational resources and time, often involving specialized hardware such as GPUs or TPUs. This high computational cost can be a barrier to entry for individuals and organizations without access to these resources. Understanding these limitations is important for developing more effective and responsible AI systems. Don't forget to like, subscribe, and hit that notification bell to stay updated with more tech insights. Drop your questions in the comments below. We'd love to hear your thoughts.